You'd think electricity is just something that flicks a switch, lights a bulb, that it's all wires, plugs, forget about it. Nah, think again. The forces behind electricity are a billion times stronger than gravity, and yet you don't feel a thing. So what gives? What if I told you, if the balance of charge in your body shifted by just 1%, the push between electrons would be strong enough to lift the entire Earth? I'm not being dramatic, that's real. And this is just the start. Look around. Buildings, bridges, mountains. All that stuff stays together because of electrical forces, not gravity. The Empire State Building barely moves in the wind, not because it's tough guy magic, but because electrons and protons are locked in this invisible, almost perfect balance. You mess with that balance even a little, and it's game over. Matter itself is a tightrope walk between attraction and pushback. Take two tiny chunks of matter, neutral overall, still, boom, they can pull together or shove apart. Why? Individual charges talk into each other. Atoms stick together, electrical forces. Chemical bonds, same deal. Steel being hard? Yup. Rubber being soft? Also electricity. Everything you touch is shaped by forces you never see. All matter's built from positives and negatives. Like charges, they repel. Opposites, they attract. But unlike gravity, which only pulls, electricity can push back, and it does it hard. Balance keeps things stable. You lean out of balance for a second, and the forces go absolutely nuts. So why don't electrons slam into the nucleus? Why doesn't everything just collapse into itself? Quantum mechanics. You squeeze an electron too tight, it fights back. The uncertainty principle kicks in. Try to trap it, and it gains momentum. That resistance? That's what keeps atoms stable and lets life exist at all. Inside the nucleus, protons should be tearing each other apart. They're all positive, but they're held together by nuclear forces, even stronger than electricity, just real short range. That's why uranium nuclei are barely holding it together, and when they break, unbelievable energy. Yeah, Feynman called it electrical energy overpowering nuclear glue. You can hold a cup, shake a hand, stand on the floor. That ain't gravity doing the heavy lifting. It's electrons pushing back against electrons. Without that, you'd fall straight through the planet. Close your eyes for a sec. Feel your body. Your shape, your weight, your solidity is an electrical sculpture, balanced down to the tiniest detail. Some materials let electrons roam free. Those are conductors. Others lock them down tight. Insulators. Copper, rubber, plastic. It's all about how electrons are allowed to move. Now here's the real head scratcher. What holds an electron together? It's pure charge. Shouldn't it blow itself apart? Maybe, maybe not. The electron's a point particle. Electrical forces act between charges, not on themselves. Even today, we don't fully get it. Picture a universe where charges aren't balanced. 1% extra electrons, and mountains start floating. Oceans go wild. The universe feels solid only because balance is the default. Every structure, every material, every reaction, an electrical ballet, tight, precise, unforgiving. The chair holds you up, the floor pushes back. Your fingers tap a keyboard, nudging electrons exactly where they gotta go. Electricity ain't just current in a wire, it's the rhythm of matter, the heartbeat of the universe. And this is only the beginning. Next time, we'll get into how moving electrons make magnetism, how circuits tame this force, and how all this powers the modern world. So next time you flip a switch, remember, a billion times stronger forces just played nice to light your room. Electricity isn't just a tool, it's the universe doing its thing every second of your life.